Hello again, geometry students. Mr. Cruze here, this time with your geometry notes that you may have missed today, Wednesday, May 15th, 2013. Today we talked about segment lengths in circles. Okay, so as promised, there's a link in the description if you want to download these Microsoft Word notes. You can print them off, and you can take notes along with me. Okay, but I'm basically going to explain to you what you missed today in class. All right. So you might remember yesterday we talked about angle measures. Well, we're going to talk about segment lengths today. So there is a special relationship between two intersecting chords. Okay, so chords are inside the circle, so it might look something like this, right? Also two intersecting secants, which might look something like that. Okay, and there's also maybe a secant and a tangent. Okay, so we can find lengths of unknown segments. For a given point in circle, the product, so product is going to be multiplication, of the lengths of two segments from the point to the circle is constant along any line through the point and the circle. So there are basically three cases. Case one is the chords. Okay, and I'm drawing the chords as non-specific as I can. But anyway, if this little piece is A, maybe I should make it a little bigger so you can actually write some of this in. If this little guy is A, this little piece up here, and this piece down here is B, and this part's C, and this part's D, then there's a nice little relationship. A times B equals C times D. It's that simple. You just take this piece times this piece, and it equals this piece times this piece. The proof of this comes from similar triangles, but we're not going to worry too much about that. Okay, so we're just going to keep moving along here. Case 2 involves two secants. So I'll label these pieces as that's W, this is X, we'll label this as Y, and this will be Z. Okay, so X and Z are inside, W and Y are outside. Now, this isn't as simple as case 1. Case 1 is actually the easiest case. Case 2, you take the part that's outside, which in this case, the part that's outside is W, right? So I'm going to take W times, and then you take the whole segment. Well, how long is this whole segment? Well, if this were 5 and this were 3, you tell me, Mr. Cruze, that's 8, because you added them together, right? So the whole segment is W plus X. So you take the part that's outside times the whole segment. Guess what? That equals the same thing in the other secant. The part that's outside, which is Y, times the whole segment, which is Y plus Z. Okay, so a little more complicated than case 1, but not too terribly difficult. All right. Case 3 is very similar to case 2. In fact, it basically follows the same rules. But what happens if I have a tangent and a secant? Well, I'm going to label it almost the same way, except there is no Z this time. There's no inside the circle on the bottom part. But you still follow the same rules. You take the part that's outside, which is W, times the whole segment, which is W plus X. That equals the part that's outside on the bottom. Well, how much of this is outside? Y, all Y of it. Times, well, how long is the whole segment? Y. So Y times Y is actually Y squared. So these two, case 2 and 3, are actually kind of the same in a way. Case 1's really the different one, but I think case 1's the easiest. Okay? So as long as you can understand these relationships, you should be all right. Okay? So I'll go through a few examples here with you. Find the value of Y. Well, I see that it looks like case 3, almost exactly like the one I drew, right? So I take the part that's outside, which is 2, times the whole segment. So I take 2 plus 9, and that equals Y times Y. The part that's outside times the whole segment, which is just Y. 2 times 11 equals Y squared. So 22 equals Y squared. So how do I get Y by itself? Well, you have to grab your handy-dandy calculator, and you basically take the square root of 22. And your book will say round to the nearest tenth, so it's 4.7. Okay? Pretty simple. Example 2, it looks like case 1. So I basically take this piece times this piece. So I do X times 10, and that equals this piece times this piece, 6 times 5. So 10x ends up equaling 30, which means x equals 3. Again, just like before, these are basically algebra problems. You use the geometry to get it set up, but it becomes just a solving an equation. Okay? Find the diameter of circle O. So we're going to find this whole segment eventually. I know that part that they gave us down there is 3. I also happen to notice, since this is a diameter and it's perpendicular, since this is 7, this is also 7. Because remember, a diameter was a perpendicular bisector to a chord. Okay. If it was perpendicular, it was a bisector as well. So I'm going to call this length here x. And then it looks exactly like case 1. You take x times 3, and that equals 7 times 7. So 3x equals 49. You divide by 3, x ends up being 16.3. It says round to the nearest whole number, or nearest tenth, sorry. Now, it does say find the diameter. It doesn't say find x. It says find the diameter. So would you agree the diameter is actually x plus 3? So diameter equals 16.3 plus 3, which is 19.3. Okay? Example 4 looks exactly like case 2. So I take the part that's outside, 8, times the whole segment, which is 18, 8 plus 10, right, equals the part that's outside, times the length of the whole segment, which is 9 plus x. 8 times 18 is 144. This part you distribute. You get 81 plus 9x. Remember, I can't combine those. Algebra won't let me, right? Subtract 81. I believe you get 63 equals 9x. Divide by 9. X ends up being 7. Okay? Pretty neat stuff. It's not very difficult. Like I said, it's mostly algebra. Okay? Find the values of x and y. Well, I happen to notice x here. I happen to notice these two chords or arcs are congruent, which means these two chords are congruent as well. So that's 7. And also, it's a perpendicular. And if one notices, this is a right triangle, and the hypotenuse is 15, which means I can use Pythagorean Theorem. X squared, remember Pythagorean Theorem, a squared plus b squared equals c squared, right? X squared plus 7 squared equals 15 squared. X squared plus 49 equals 225. X squared equals, I believe, 176. So x ends up being 13.3. It will say round to the nearest tenth. Now I just need to get y. Well, if this is 13.3, I have a case 1 scenario. I've got this segment and I've got this one, right? So I'm going to take 13.3 times y equals 7 times 7. 13.3y equals 49. You divide both sides by 13.3, and you get, when you round, 3.7. Okay? That's basically what you missed today in class, okay? Your assignment is page 795, 15 through 20, 24 through 26, 32, and 33. You can add this to last night's, the page 794. If you have any questions about this at all, leave a comment in the video. Twitter me, at Mr. Cruze Math. Email me, cruze@brownsburg.k12.in.us. You can always stop in early in the morning. Okay, I am here to help you. I want you to do well on this upcoming quiz, all right? Thank you very much. Have a good evening.